Hello guys, in this video we are going to discuss the solution of the problem minimize the height to. So let us look at the problem statement. The problem statement says given an array ARR denoting height of n towers and a positive integer k. For each tower you must perform exactly one of the following operations exactly once. Increase the height of the tower by k or decrease the height of the tower by k. Find out the minimum possible difference between the height of the shortest and tallest tower after you have modified each tower. Note, it is compulsory to increase or decrease the height by k for each tower. After the operation, the resultant array should not contain any negative integers. So for instance, if this is the array which is given to us and the value of k equals to 2, the minimum height which is possible over here is 5. And this height can be obtained by manipulating the array in this fashion, which is to increase the height of first tower by k and decrease the height of remainder towers by k. After that manipulation, the height of towers will look something like this: 3, 3, 6 and 8, and the minimum difference between the largest and the smallest tower will be given by 8 minus 3, which is equals to 5, and that is why we are returning 5 over here. So that's about the problem statement, folks. Now let us discuss the solution of this problem. So in order to discuss the solution of this problem, let us take an example. So let us say the height of the tower which is given to us is this, and the value of k equals to 2. And let us make one assumption, which is at this point we are not supposed to increase or decrease the height of the tower. If we go with this assumption, then in order to get to our answer, all we have to do is we have to compute all the pairs and find the diff between them. So for instance, if this is the array which is given to us, the possible pairs over here are 3, 5. So these are the possible pairs for this particular array. So let us compute the difference between the pairs. So over here the difference is 2. Here it is 5, 7, 5, 3 and 2. And since we have to return the minimum difference, and the minimum difference will be given by this pair. So over here, as we can see, we are computing the difference between all the pairs. So the first optimization over here is to minimize the computation of all pairs. And how can we minimize this computation? Well, we can minimize this by sorting the array. So for instance, if we look at this array, and this array was already sorted, as we can see, the difference between these pairs, which is 5 and 7, will always be greater than 2. Similarly, the difference between this pair will always be greater than the first pair. So in a sense, what I'm trying to say is, if the array is sorted, then we just have to compute the difference between these pairs. And we don't have to worry about these pairs. Because since the array is already sorted, the difference between the first pair will always be lesser than the difference between the subsequent pairs. So for instance, over here, if you see, this is the first pair, 3 and 5 is the first pair, 3 and 8 is the second pair, 3 and 10 is the third pair. Since the array is sorted, the difference between the first pair will always be lesser than the difference between the subsequent pairs. Using that property, we are going to just compute the difference between the adjacent pairs rather than computing the difference between all the pairs. So that is the first level of optimization, which we can obtain by sorting the array. Now let us say there is some array which is given to us and we have already sorted that array, and the sorted array looks something like this, which is A, B and C and D, which simply means A is less than B, B is less than C and C is less than D. So this property holds. Now from the first level of optimization, we understood that rather than computing the difference between all the pairs, all we have to do is we have to compute the difference between AB, BC and C and D. So this is the first level of optimization we have done. Now let us reintroduce the concept of increasing the height of the tower by k or decreasing the height of the tower by k. So let's pick any pair. So let us say I am picking pair A, B. Now with this I have two options. Either I can increase the height of tower by k or I can decrease the height of tower by k. Similarly with B, I have two options, whether to increase or decrease the height of tower by k. With this, I have 4 combination, which is I'll increase the height of tower by k, I will decrease the height of tower A by k and increase the height of tower B by k, or I can increase the height of tower A by k and decrease the height of tower B by k, or I can decrease the height of tower by k. Now with this, let us compute the difference between the height of the towers. So this will give us b minus a. This will give us b minus a plus 2k. This will give us b minus a minus 2k. And this will give us b minus a. So with these four combination, which combination gives us the minimize height? Well, this is the combination which is giving us the minimize height. So for that reason, whenever we are iterating on a pair, let's say we are iterating on a pair A comma B, what we are going to do is, we are going to increase the height of tower A by k and decrease the height of tower B by k. And then we are going to compute the difference between these two, and that should give us our answer. And finally, folks, there is one more concept which we need to understand in order to solve this problem. So let us say the array which is given to us was A, B, C and D. And please note this is sorted. So A is less than B, B is less than C and C is less than D. Now let's say we are operating on the pair B comma C. Now from the first two concepts we realize that we have to increase the height of tower B by k and we have to decrease the height of tower C by k. Now after increasing and decreasing the height of the tower, we don't know which is the tallest tower and we don't know which is the smallest tower. And in order to compute our answer, we have to answer these questions. So let us try to understand what would be the tallest and smallest tower in this scenario. So to understand this, let us first look into this array. So remember, this array is already sorted. Now since this is the sorted array, so this is the minimum element and this is the maximum element. And our objective is to compute the difference between max height tower minus min height tower. And within this, our objective is to minimize this. So we want to minimize this. In order to minimize this, what we need to do is we need to minimize this and maximize this. So in a sense, what we are trying to achieve is we want to minimize the height of the maximum tower and we want to maximize the height of minimum tower. So the minimum height will be given by max of min of A, since A is the tower with the minimum height, comma C minus K. By subtracting K from C, it might be possible that this becomes lesser than A. So that is why the difference between these two will give me my minimum height. Similarly, the max height will be given by maximum of D, since D is the tallest tower, comma B plus K. And folks, since we have to manipulate the height of the tower, so A and D both have to be manipulated. Now we have an option of either increasing or decreasing the height of tower A and D. Since our objective is to minimize the difference, so when we are computing the minimum height, our objective is to maximize its height. For that reason, this has to be plus K. Similarly, when we are maximizing the height, our objective is to minimize the height, because of which this will be minus K. And folks, in this way, we will be able to compute the minimum height tower and maximum height tower. And once we have computed this, all we have to do is we have to compute the difference between max height and min height. So that's the discussion of solution, folks. Now let us discuss the pseudocode of this problem. So let us say we want to minimize the height and an array is given to us. So as we have discussed, the first thing which we want to do is we want to sort this array. And let's say n is equals to len of array. Now let us iterate on the array I for I equals to 1 to len of array. And then let's see if arri minus k is less than or equals to 0. If it is less than or equals to 0, then since we are not supposed to make the height of tower 0 or negative, because of which we are just going to continue from here. Otherwise, we are going to compute the minimum height and the minimum height will be given by min of first element 0 plus k, or it might be possible that by decreasing the height of tower I by k, we might be able to get the minimum height tower. Similarly, max height equals to max of last tower, so ARR of n minus 1 minus k, comma ARR I minus 1 plus k. And in this way, we have computed our min and max height. And for answer, all we have to do is answer equals to minimum of answer, comma, max height minus min height. And towards the end, we just have to return answer. And folks, I hope this part is clear. The reason why we are iterating on I, I minus 1 is because the array is sorted and we are just iterating on the adjacent pairs. So that's the pseudocode, folks. Now let us see how we have implemented this in Python and C++. So first thing which we are doing is we are sorting the array, and then we are computing an answer which is the difference between height of last tower and first tower, and then we are iterating on the rest of the elements. We are computing temporary minimum and temporary maximum, then an answer which is equals to minimum of answer, comma, temp max minus temp min, and towards the end we are returning answer. So that's the Python implementation, folks. Now let us submit our solution. So our Python solution got accepted. Now let us look at the C++ implementation. So it is also the same, folks. We are sorting the array, then an answer, temp min and temp max. We are computing temporary minimum and temporary maximum, then answer, and towards the end we are returning answer. So that's the C++ implementation, folks. Now let us submit our solution. So our C++ solution also got accepted. That is all from this video, folks. In case if you have any question or comment regarding this video, please feel free to use the comment section and I'll try to address them. Thank you.